Hello everyone. Today we'll be going to solve this question from GFG, first repeating element. Given an array ARR, find the first repeating element index. The element should occur more than once and the index of its first occurrence should be the smallest. Okay. So in this question, what you're given is we'll be given an array and it will contain duplicate elements. And we have to find the element which got duplicated, like the element which is positioned inside the array first, and it also contains a duplicate. Okay. We have a note over here which says that the position of your return should be according to the one base indexing. This is important for us because normally the array starts from indexing 0 to 1 2 till n minus 1. This In this question we have one base indexing. Okay, and let's see the example here. The example says this is the array, right? And the output is 2. Why it's 2? Since it's one base indexing, so this position will be 1, this position will be 1, this is 2, it's 3, 4, and our correct answer is 2. Why? The 5 appears twice. Okay, the 5 appears twice, and its first appearance is at index 2, which is less than 3, whose so you can see here 3 also occurred twice, right? 3 also occurred twice, and 3 even got repeated before 5. Okay, if you see array till this part, 3 got repeated till that. Okay, but 3 is not the correct answer. The correct answer is 5. Okay, so we have to find this solution for this. I've found three approaches to solve this question. One is brute force, that is optimal with two pass of hash map, and another is optimal with one pass of hash map. Okay, so as you can see here, this is one base indexing for you. So rather than starting from 0, it starts from 1. Okay, uh these are the two constraints given to us, the one base indexing, and we have to return the first duplicate value. Okay, so the global min is required, not just the local one. So in this part you can see for this array the local answer will be 3. This index will be returned, but for the whole array we know 5 is the correct answer. Okay, so what we have to do is, for the brute force approach, we have to traverse over array. Okay, and then pick one element while iterating, and then we'll traverse again over the leftover array. So what do you mean by that is, first, uh, we as we picked one, now we will search one in this left part of this array. Okay, the part here we have to find one. We didn't find one, then we can move to the next one, right? Now for 5 we have to search in this whole array. Okay, we found 5, we store this index 2. Okay, store this index, have a min to store the minimum index for duplicating element. Okay, return min plus 1. Why? Because we have one base indexing, or minus 1 if it didn't exist. You can see this second example over here, that there are no duplicate elements, so we have to return minus 1. Okay, so this important justification that I wanted to share with you was the 5, the first index is 2. For the 3, the first index is 3. So you might feel while traversing that 3 repeated first, so it should be the answer. But the minimum of 2 and 3, the minimum of 2 and 3 suggests that answer is 5 in this case. Okay, so from this is the reason why you have to store a min rather than directly return it. Okay, do not return instantly, as it won't give correct results according to the constraints of the questions. Okay, so let's code this one, and then we'll see other approaches to solve this question. First thing, we need a utility as int n is air dot size. Then we have to loop twice, right? So for int I equals 0, I less than n, I plus plus, and then we have to put in again another loop as for int j equals to I plus 1. Why j is equal to I plus 1 is because once we have picked this element, then we have to traverse from this part to this part. We cannot include one, because obviously if we included one again, then first one will be always be a duplicate. Okay, so for j is equal to I plus 1, j less than n, j plus plus. If ARR of I equals ARR of J. If they are equal, then I also discussed that we need a minimum variable. So I'm going to name it as answer, and I will store int max inside it. I'll store int max so that once we found something, it always replaces it. Okay. On a answer is equal to minimum value of I comma answer. So whatever will be minimum will be picked. Okay. And if now once we have done we are outside both of the loops, now we can directly return our answer as we need something like a ternary operator to finalize this. So what you can do is, if answer is not changed, if answer is still int max, okay, the answer is still int max, that means there were no duplicate elements like in this case. Okay, then what you have to do is we have to return -1. Okay, then what we have to do is we have to return -1, else we can return answer +1. Why we are doing +1 is because we have one based indexing. Okay, so let's compile this one, and we have done this, and we got a time limit exceed. Okay, so this since that this is an O of n square approach, and we have to simplify this. Okay, the other two approaches simplifies this question to O of n. Okay, so this approach was O of n square. The next two approaches that we'll discuss will be O of n. Okay, so let's just remove this part and discuss the second way to solve this question. Okay, the second way will be using a hash approach with two passes. This will be O of n. The same question. Okay, what we have to do is in this one we have to create a hash map. Okay, this is a hash map. It will look like this, and this will be a frequency hash map. Okay, this will be a frequency hash map. Frequency hash map. Okay, what we are going to do is we are going to traverse over the array, and then we are going to create something like this. Okay, this is a hash map. We are going to create something like this, and then for the second traversal, we'll pick the first element that is greater than 1. Okay, so as you can see, we traverse over the whole array, and we can, when we stored it like 1, we came came upon 1 time, the first one, then it came upon 5 second time, 2 times, here 1, here 2. Same way we have built this hash map. Okay, now what we are going to do is uh, we we know one thing, that hash map destroys or like it disturbs the ordering. Okay, so what you're going to do is to keep consistency over a hash map will be traversing over the array and using hash map as lookups. Okay, and the lookup time complexity is O of 1, which preserve ordering. This is for average case. Okay, so what why we are still able to find correct answer even when the ordering is destroyed, although this is correct ordering, but ordering will be destroyed. Why we are still able to find is because we'll be traversing array. So once we traverse this part or this part or this part, we'll find it the first. Okay, so we traverse from the starting to end. By this way we are going to utilize the hash map to find a answer. Okay, so let's code this one and then see the third approach. So first we'll need a utility. Int n is equal to arr dot size. Now we needed an unordered map, right? Unordered map. Okay. Int int one int for the key pair and one for the key. One int for the key and another int for the value. And I will name it as frequency. Frequency. Okay. So we'll be storing frequency in this. First we need one pass for storing the frequency. So for int I equals 0, I less than and I plus plus frequency of ARR of I plus plus. So what we are doing is we are increasing the frequency of this key. Okay, ARR of I is our key and we are incrementing this counter. Okay, now what we have to do is we have to iterate again for int I equals 0, I less than n, I plus plus. If frequency of ARR of I is greater than 0, okay, sorry, it's greater than 1, frequency of any value is greater than 1, then we have to return it. Okay. Then we can directly return it because, and we can directly return this because we are traversing the array from starting to end. Okay, we are traversing array from starting to end. So the first time we encounter a duplicate, we can directly return it because it will be the smallest one. Okay, so then we have to return I plus 1. Don't forget to do this plus 1. Okay, because one base indexing. And if we came out of this loop and we have still haven't returned anything, okay, then we can safely return -1. Okay, because that means there are no duplicates. Okay, now let's compile this, let's submit this, and we have submitted this one. Okay, next thing we have to do is we can do the third method. Okay, we can use the third method. So for the third method one, what we have to do is we have to rather than storing an array of frequency, we are going to store the first index. Okay, so once we reach each of these elements, we are going to store the first indexes. Okay, we reached 1, we stored 1 over here. We reached 5, we stored 2 over here. We reached 3, we stored 3 over here. We reached 4, we stored 4. We reached 3, we found 3, so we are not going to store anything. Okay, we are not going to store it. Okay, so now what we can do is we have to initialize hash map, and in answer, if the element already existed inside the map, then modify answer according to the and store min. Okay, else store the new entry inside hash map. And finally, you have to return answer or -1 according to our requirements. Okay, so let's code this one. Now in this one, what you have to do is we need another hash map, but this time we are going to store first index. Okay, so unordered map int int first index. Okay, I'll name it first index. Now we need one for loop for int I equals 0, I less than n, I plus plus. And now we have to keep a condition. Okay, so what will be the condition is for if first index dot find ARR of I is not equal to first index dot end. Okay, so this line means is if this is a function of hash map. Okay, so it will find ARR of I, and if ARR of I is not, for ARR of I, the value inside the first index is not if first dot end. Okay, what does that mean is once we reach, let's say we reach 3 over here. Okay, so if we reach 3 over here and we already have something stored for 3, that means for the value 3, it's not pointing to the end of the hash map. Okay, the empty part of the hash map, the end of the hash map, it's not parting over here. So then what you have to do is we can just say that this is a duplicate case. Okay, then we have to store a min. Okay, so int answer is equal to int max, same as the brute force approach. Okay, answer is equal to minimum value of answer comma first index of ARR of I. Okay, either the first index of ARR of I or something already stored inside answer. We have to pick a minimum. And if we didn't find the value, okay, let's say here we were here, okay, we are at 3 and there were no entries like this, okay, there were only these two entries, so there was no 3 at that time, okay, then what we have to do is we have to create a new entry for this one, okay, then what we have to do is else what we have to do is first index of ARR of I is equal to I, so we are storing the index, okay. Now after all this for loop, we have to return same way as we returned in brute force, okay. So if answer is equals int max, if answer never changed, that means we have to return -1, else we have to return answer +1, okay. This is same from brute force, okay. And this is the part for the new one pass hash map, okay. Now let's compile this and let's submit. So as you can see, it's also submitted. So this way we have solved this question with 3 of the best approaches to solve this question. Okay. Thank you for watching.